Hey, what's up, guys? This is Chung here. So today, LeetCode number 503, next greater element number 2. So you're given like a circular array, right? And then basically, so the next element of the last element is the first element of the array. That's what the circular array means. Okay, and you need to print the next greater number for every element. So in a circular array, right? So which means that, for example, if we have 1 to 1, right? So for 1 here, the next greater number is 2, right? And then for 2, obviously there's no greater number in this array. That's why if we cannot find the greater numbers, next greater number, we put -1. And for 1 here, so since there's nothing on the right side of 1, so we have to loop through. Basically, we have to search from left again, right? That's why we have another 2 here. And the length of the given array won't exceed 10,000, right? I mean, so for this one, I mean, a brute force way, of course, is basically for each of the elements here, right? We search the entire array, right? So we search it until basically we search from the current array to the end, and then we go back to the beginning, and then we search to the let's say we have a x here, right? So let's see if we're trying to find the next greater number for this one. We search until to the end, and then we try to search it again from the beginning until here, right? And obviously this is going to be a of n square time complexity, right? And think with this kind of constraints here, it might TLE basically. So how can we improve it, right? For this kind of problem, find the next greater numbers, on the right side. It's always it's the common solution is by using a stack, basically. So where did that n squared, this additional n coming from, right? Basically coming from, let's say we have this kind of array here. We have 10, 9, 8, 7, 6, right? So basically for each of the elements here, we have to loop through to the end. And for this kind of 9, 8, 7, 6, we process them multiple times. That's why we have this kind of O of n squared, right? But if we can use like a stack, basically, we're maintaining like a decreasing stack, So we push. So here's another example. Basically, if we have like 10, 8, 7, 6, 9, 7, 6, 5, 8, 6, 5, 4, and 7, right? So as you guys can see, basically, every time when we see a smaller numbers, we push it into the stack. So basically, we will have like this into the stack at 10, 8, 7, 6, and 9 in the stack at the beginning, right? And then we see a 9 here. Every time we see the current number is greater than the top elements in the stack here, basically we know, okay, we have find the next greater number for the current element, right? Because that's the first number that's greater than the current one. We can just simply remove this one, remove it from the stack, because we have already find the answer for that. There's no need for us to leave it into the stack. Right, so this one is gone. This one is also gone. 7 for 7. The next greater number for 7 is also 9. And the 8 is gone. So now we only have 10, 9 left in the stack. Right. Similarly, then we have 7, 6, 5, and then we have another 8 here. Right. So for 8 is greater than 5, greater than 6, greater than 7, and then we put 8 here. Similarly for this one. Right. And then we have 7. So this one is gone. This one is gone. And 7. Oh, by the way, so we push the index, not the value, right? So basically, after after the for loop for using the stack here, we will end up having like a decreasing stack, right? And then what's left in this stack here, we have to somehow handle it, because those are the ones basically those are the index that we cannot find the greater number on the right side. So which means that we have to find it from the left side. right? And we cannot reuse the stack itself because we might have already missed some of the records. So that's why we have to loop through from the beginning one more time. And why is that? So we have, let's say we have 1, 2, 3, 3 to 1, right? So for this one here, let's say for the last element, which is 1. So what's the next greater number for 1? It's 2 actually, right? But our stack, after processing this array for the first for loop here, the stack will end up with like 2, 3, and 1, right? That's the stack will end up. But for this one here, we need to find find the first greater number from the beginning one more time, right? That's why we have to do another for loop from the beginning, and every time when we have a number from the beginning, we check if that number is greater than this one first, than the top one in the stack. If it is, then we know, okay, so that one is the next greater number. I mean, from the left side. So now, as you guys can see, since we only push and pop each element into the stack once, so now time complexity will become to O of n, right? Yeah, I think that's basic the idea. So let's get on to the coding here. And okay, so we have an n here, and then we have a at the beginning. I initialize everything into -1, right? And then we have a stack equals to this one, right? And then for I in range of n, right? So we want to maintain like a decreasing stack, right? Basically, while stack and the numbers of I, or if the current one is greater than the top one in the stack, right? Remember, we store the index in the stack. That's why we have to use the stack, the value from the stack plus the numbers to find the actual value, right? So if this is the case, we know, okay, so this nums I is the next greater number for this index, right? That's when we just simply just do a update the answer, right? And the index for the answer will be the stack.pop, right? Since we need to pop this thing out because we already find the next greater number for this current index, and the number will be the current numbers, right? And don't forget to append to push this the index into the stack. So like I said, after the first for loop here, we have already find the answers for the index who has the next greater number on its right side, right? So now let's handle the next greater element on the left side. Okay. Since we want to find it the first one, that's why we have to loop through from the left side one more time, right? Similarly, actually I can simply just copy these things again, right? Since it's the same logic here, if the current one is greater than than what's left on the top one in the stack, I update that, right? And then in the end, I simply return the answer, right? Basically, we simply loop through this array twice. Okay, so if I run the code, accept it, right? So passed, right? Well, actually, so I think we can do a little bit early termination here. I mean, basically, if the I equals to the stack dot -1, right? So it means that we have already figured out search everything for the top one, and we still couldn't find the next element, the next greater element, and then that's we can simply break here, basically, right? There's no need to continue because if we have reached the if there's still a one element left, in the stack, who where we cannot find the next greater numbers, and then we simply break, right? So this should also work. Yeah, but this one will not change the total time complexity. It's just a little bit a little improvement of this problem. Yeah, I think that's it for this problem. It's a very classic stack scenario, right? Where you use a stack and you push and pop each element in the stack once, so that you can easily find the next greater number in the stack, and then in the end we do a for loop one more time from left to right to handle the next greater numbers on the left side, right? So you like I said, even though we have a while loop inside the for loop here, but since we're only push and pop the stack once, so here it's actually it's a O of one, right? That's why the total time complexity for this one is like O of n, right? Cool. I think that's everything I want to talk about for this one. And thank you for watching this video, guys. Like always, stay tuned. See you guys soon. Bye bye.